Guys, good morning. Today we're going to continue talking about functions, okay, and they are really important for you to know. So on the EOG, you'll be fine. So we're on page 94 in your books. Okay. Today we're going to talk about comparing linear functions. Linear functions can be represented in different ways. The y-intercept is initial value. It's going to be the value that you start off with. And the slope is the rate of change. And it can be determined from any representation, so functions that are represented differently can still be compared. So you're going to have three different things that you're going to have to know. First is forward description. Okay, and this is just, it gives you a sentence. So Maria opens a savings account with $30 and then deposits $20 every week. Okay, what does she start off with? $30. Okay, since that's her initial amount, that is going to be her y-intercept, or her b. And then $20 every week. Okay, that is a rate. Okay, so every week that goes by, she is gaining $20. So that is going to be my rate of change, my m. So I have my initial value and my rate of change. And if I would put that into y equals mx plus b, the equation of that would be y equals my m, which is 20x, plus my b, which is 30. Okay, and that's how you would write in the equation. The second one is a table. Okay, your initial value is the amount when time equals x equals 0. So whenever x is 0, you know that's going to be your y-intercept. Okay, when does x equal 0 over here? Up here. So my y-intercept is going to be 30 because x equals 0. The rate of change is the ratio of the difference in the amounts of corresponding differences in time. And to do that, we're going to use our slope formula. M equals y2 minus y1 over x2 minus x1. Okay, we're going to pick 2 points. So I'm going to pick 0, 30, and then I'm going to pick 1 and 50. Okay, and I'm going to plug my points in. Y2 is 50, y1 is 30. X2 is 1, x1 is 0. Do my math. 20 divided by 1 is just 20. Okay, and that's going to be my rate of change. Okay, they can also give you an equation. Okay, the number besides your x is your slope, and then the number that doesn't have anything to it is your y-intercept. Okay, let's say if there was not a number, okay, then that would mean your y-intercept is 0. But since we have a number, my y-intercept is going to be 30. Okay. And you can also look at a graph. Okay, your y-intercept is where it crosses your y-axis. Okay, and where does it cross my y-axis at? 30. And then your slope is going to be rise over run. Is this going to have a positive slope or a negative slope? A positive because I'm increasing left to right. So I'm going to draw my little triangle, make sure it goes through a whole number. Okay, over here, what is each box counting by? 10. And down here, 1. So I rise 2 boxes. 2 boxes is 10 each, so I have 20 over 1. And simplify that, it will give me 20. So my slope is going to be 20, and my y-intercept is going to be 30. So which function has the greatest initial value? An initial value is a keyword for what? For y-intercept. Okay? So over here, what is my y-intercept? 8. Over here, okay, when this x equals 0, right here, so my y-intercept is 0.75. Which one has the greater? Function A. Okay, and look down here. Which one has the greater rate of change? So this time we're looking at my slope. So I'm going to draw my little triangle. Okay, each box over here. Now notice how I skip one. Okay, so you can fill it in. So over here it's counting by 5s. Down here it's counting by 1s. So I rise 2, so that's going to be 10. 2 times 5 is 10. And how many do I want? 1, 2, 3, 4, 5. So I have 10 over 5, which is going to give me 2. So my slope over here is 2. Over here, an Apple Orchard charges $5 just to visit. So before you even start anything, it's $5. So that's your initial amount. And then $4 per basket of apples. So what is my rate? 4. Which one has the greatest rate? 4 or 2? 4 does. So function D is my answer. Let's turn the page. Demetrius compares a pair of functions. One function is represented by the equation y equals negative 3x plus 1. The graph of the other function is shown below. Which of these statements is correct? Okay, and if I look, they're all talking about my y-intercept. So I'm going to find my y-intercept for both ones. For the equation, what's my y-intercept? 1. Okay, for my graph, where does it cross the y-axis? Negative 2. Okay, so let's read. Both the functions have a positive y-intercept. Are they both positive? Nope. Both of the functions have a negative y-intercept. Are they both negative? No. The function represented by the equation has a positive y-intercept, and the graph has a negative. Yes, that is true. My answer is C. Consider the function represented by the equation y equals 1/3 x plus 2 and the one represented in the table. Which of the following is true? Okay, so now this is talking about, are these the same? Okay, and in order to see if they're the same, I'm going to have to make an equation to this table. Okay, so we're going to look at my table. First of all, we know y equals mx plus b. That is an equation. So we'll have to do this and make it into an equation. So the first thing we're going to do is find my b. When does x equal 0? Right here. Okay, so when x equals 0, my y-intercept is negative 2. Now we have to find my slope. In order to find my slope, we have to use my slope formula. Okay, we're going to pick 2 points. It does not matter which one you use. I always use the first 2. I'm going to plug in my information. Negative 3 minus negative 4. Negative 3 minus negative 6. These become positive. I'm going to get 1 over 3. So now, this table is y equals my slope, 1 over 3x minus 2. Are these the same? No, they are not the same function. Both functions have the same slope. What is my slope of this one? 1/3. What's my slope of this one? 1/3. Okay? So my answer is going to be B. And again, we have done this before, so this should just be a good refresher. The graph shows the approximate relationship between the price per luxury shirt in dollars and the number of shirts ordered from brand A. The same relationship from brand B, so this is brand A, this is brand B, is represented by the equation y equals 24 minus 16x. So like all of that is true. Okay, well let's look at it. What is my starting value for this graph? Okay, so it's counting by 2's. So what's my starting value? 20. Okay, what is my value here? 24. Now it doesn't have to be, your slope is not always the first one. Okay, your y-intercept is the constant, it's the number, it doesn't have any x attached to it. Okay, so let's look. The starting cost per unit of brand B is $24 per shirt. Yes. Okay, but they want us to select all that applies. B, the rate of change for the function up. Now we need to find my rate of change. What's my rate of change for here? So let's figure that out. Okay, draw my triangle. First of all, actually I can draw one right here. Am I going to have a negative or positive slope? I'm going to have a negative slope because my line is decreasing. Okay, over here, each box represents 2. Over here, I'm counting by 10, so each box is going to be 10. All right, so how many am I rising? 1. I have 2, and how many am I running? 1, so 10. Simplify that, and I'll get negative 1/5 for here. Okay. And then I have negative 1/6 down here. The rate of change of function brand A is less than the rate of function of brand B? No, it's greater than. The rate of change for the function of brand A is greater than the rate of change for brand B? Yes. Okay. D, the slope of the function of brand A is negative 10? Nope. The y-intercept for the function representing brand A, okay, so 20 is greater than brand B. No, because brand B is 24. So my answer for this one is just A and C. Okay, so you're responsible to do the back. However, I am going to give you a little hint. Okay, let's look at number 1. It says, which of these functions have the same rate of change as a function whose graph of a line with an x-intercept of 12 and a y-intercept of negative 15? So x-intercept is going to be your number when y is 0. Okay, so it's going to be 12, 0. Your y-intercept is when x is 0, negative 15. So now what you're going to need to do is use these points, plug it into your slope formula, and whatever answer you get, match it to one of these up here. Okay? And this is for homework, and I just need a picture of this. Okay, let's move on to this next one. Analyzing and draw graphs of functions. Okay? A graph can be used to model the functional relationship between two quantities. The graph may or may not include numbers on the axis. Graphs may be linear, nonlinear, or both. It may contain sections showing the graph increasing, decreasing, or remaining constant. A meat thermometer measures the temperature of a chicken roasting in the oven. The graph shows the changes in temperature as the chicken cooks. Okay, so here's the temperature and here's the time. So as time goes on, what's happened to the temperature? It is increasing. Okay. Using the labor graph, we're able to draw conclusions and answer questions about different temperatures at different time intervals. The non-labor graph gives us a general idea that the temperature of a chicken rises slowly at first and then more quickly until it begins to taper off. Okay, this graph shows Naomi's distance from her home during a bike ride. She leaves home and rides to her friend's house. Okay, so if you look, this is the distance. Okay, so at 0, at ground level, she is at home. Okay, and this is your time. So time keeps going, okay, but distance is going to change. So she leaves home. So here's Naomi going. Okay, so as time goes on, what's happening to her distance? She's getting farther. She visits for a while. So is she increasing her distance from home? No. So it's staying the same, but what's happening to the time while she's visiting her friend? It's still going. Time don't stop. And then she rides back home. So she goes back home, but notice how the time continues going. And when she hits this x-axis, which represents 0, she's 0 miles from home. Both graphs shows Naomi riding at a constant rate until she stops and does not travel any further, indicating by the horizontal line. Looking at the steepness of the decreasing section, so looking at this section, this is more steep. So this tells us that when she was coming home, okay, she was going at a faster rate, probably because she was past curfew and she had to get home before she got in trouble. Okay? So let's look at 1. Which graph shows the relationship between time and temperature as a block of ice is heated? Okay, so as it is heated, okay, again, your time keeps going, but what happens to the temperature as it gets hotter and hotter? It goes up. So my answer is B. Okay, so again, as you heat it, your time keeps going, but your temperature goes up. And eventually does what? melt. Let's look at 2. Draw a graph to model the following situation. You're listening to music, you turn down the volume. Okay, so if you look, this is the volume. So 0 means it's completely off. Time keeps going. Okay, so if I'm already listening to music, okay, I'm going to probably start up here. So I'm listening to music, you turn down the volume, okay, so what happens? The volume goes down to talk to a friend. Again, so talking to a friend takes some time. So the volume's going to stay the same. It is not changing, but your time does. Again, your time doesn't stop. After you finish talking, you put the volume back to where you started. Here, just right here. And you continue listening to music. Okay, so this represents a constant time. Okay, you're not turning up the volume, nothing's happening, but time is keep on going. Okay. So let's do some practice problems. Okay, go ahead and pause the video and then come back. Don't do 3 for the answers. Okay, welcome back. Let's look at number 1. The graph shows Donovan's height above the ground floor while riding an elevator as a function of time. Is the graph increasing on each of these intervals? Check yes or no. Again, you're reading the graph from left to right. Okay? So, from 0 to 15, am I increasing? No. Okay, from 15 to 20, am I increasing? Yes. How about from 20 to 40? No, I'm staying constant. How about 40 to 50? Yes. And then 55 to 50 to 55? No, I'm staying constant. A jogger set to watch to monitor her heart rate during her workout and cool down. She then uploaded the data to her computer and viewed the following graph as showing the number of beats per second as a function of the distance she traveled. Alright, so this is the distance, and this is what happens to her heart rate. Where is the graph non-linear? Okay, what is a non-linear graph? It's when you have a curve. So if I look, right here and right here is non-linear. So let's try to find the interval. So it looks like 0 to 1.5. Okay, so we can go ahead and cross these out. And then from 4 to 5.5. So my answer is B. Okay, and then let's look on this side. Inflation takes place when the average price of selected goods and services rises over time. Deflation also takes place when prices fall. Okay, so I'm going to draw a graph so we can see this. So in a small town, inflation occurred for a period of time. So this is time. This is going to be inflation. Okay, and this is going to be a curve. Okay. It's not linear, it's not a constant inflation, it can change, okay, but over time, it's kind of curving like this. Then for a brief period, neither inflation or deflation occurred, so I'm just staying constant. And then, deflation happened. Okay? Again, inflation, deflation is not going to be linear because it's not a constant. The town's mayor sketches a graph of the average price of goods and services as a function of time. Which section for each of the 3 periods described select all the statements that are true? The middle section is linear. Yes. The leftmost section is linear. No. The rightmost is linear. No. The middle is horizontal. Yes. Okay, and then the leftmost is decreasing. No, it's actually increasing, and this one is decreasing, not increasing. So my answer is A and D. Okay, for homework, you do the next page, which is 126. It's just 3 problems. Okay, and that's all for today. Let me know if you have any questions. Have a good day.